Welcome, students. Today we're going to look at slope-intercept form. This is going to be our third method for graphing lines, and it's honestly my favorite method. I'm hopeful that you'll like it as well. The first method that we learned was a table of values. That's the first way that we sketched graphs of equations. Then we looked at the intercept method, finding the x and y intercepts and then connecting the dots. And now we're going to look at slope-intercept form. And to do that, we're going to want an example of a line. So let's take this one. Here we have y equals 2/3 x minus 1. Now, what I want to do is I want to look at a couple of things about this line. First, I want to take a look at the slope. Now, to figure out the slope, instead of using the formula, I'm going to draw a triangle, which is something that we've done before. Now, the slope here, if we pick these 2 points and we draw our triangle, we can see that the rise is 2 and the run is 3, and it's a positive slope because it's moving up as it goes to the right. So here we have a slope equal to 2/3. All right. I also want to take a look at the y-intercept. That's going to be an important thing here. Now, if we look at where this line crosses the y-axis, it crosses right here, which is at -1, because it's down 1 from the origin. So the y-intercept is -1. And I want to ask you, have you seen these two numbers yet today? In fact, I'm looking at them right now on this screen. 2/3 is the coefficient on the x. It's the number that's being multiplied by x. And then -1 is that constant term. And this is not a coincidence. And in fact, there's a name for this form. This is called slope-intercept form. Now, slope-intercept form says the following. The graph of the equation y equals mx plus b, this is slope-intercept form, is a line with slope m and y-intercept 0, b. So the number that x is being multiplied by, the coefficient on the x, gives us the slope. And then the constant term, the term that's just a number, gives us the y-intercept. And this is useful because if we have an equation in this form, just by looking at it, we can figure out the slope and the y-intercept. And that is enough information to sketch the graph. Let me show you how it's done. Sketch a graph of y equals -1/4 x plus 2. Now, this equation is in slope-intercept form. Y equals some number times x plus another number. So because of that, we can look to see exactly what the slope and the y-intercept are going to be. In this case, the slope, which we usually use m to denote, that's the coefficient on the x, so the slope is going to be -1/4. And then the y-intercept is going to be the constant term. In this case, that's 2. And I'm going to claim that that is enough information to draw the graph of that equation without calculating the other intercept, without making a table of values. That alone is enough to sketch the graph. Let's see how this works. Okay, so we've got the slope and we've got the y-intercept. And we're always going to start with the y-intercept because that is literally our starting point. An intercept gives us a point on the graph. Because the intercept, the y-intercept is 2, we find the point 2 on the y-axis, 0, 2, and that is going to be a point on our line because we know the line crosses the y-axis at 2. So that's literally our starting point. Now, there are lots of lines that go through that point, but only one of them has slope -1/4. So what we're going to do is we're going to use this slope to figure out where the line goes from the starting point. Now the slope is -1/4. I'm actually going to put the negative in the numerator. These are equivalent fractions. It doesn't matter if the negative's out front or in the top. And I found that students make fewer mistakes when they put that negative sign in the numerator. So here our slope is -1/4. So the rise is -1 and the run is 4. So from our starting point, we're going to rise -1. That means we go down 1 to here. And then we're going to run 4, and we always run to the right. And that puts us there. And that's going to give us the next point on our line. And in fact, we can do it again. If we're starting here, if we rise -1, that means we go down 1. We run 4, that means we go 4 to the right. That is going to be our next point. And we can even do it again, down 1 and to the right 4, and that gives us another point. Now this is clearly enough points to see what direction the line's going in, but what I want to do is I also want to get some points in the other direction, just so that when we draw the line, it's actually accurate. So far, to get a new point, we went down 1 and to the right 4, but it's also clear we can go up 1 and to the left 4, and that's going to keep us on the same line. So from here, we can go up 1 and to the left 4, and that is going to give us our next point. And we can do it again. Up 1 and to the left 4 puts us here. Up 1 and to the left 4 puts us there. And I just want to draw lots of lines so that, lots of points, excuse me, so that when I finally draw the line, even if I'm drawing it by hand without a ruler, which is kind of hard to do, it still looks like a decent line. All right, if I didn't have all of these points plotted as guidelines, it would have been a lot harder to come up with such an accurate line. But this ends up being the line that represents y equals -1/4 plus 2. And in fact, we can do this anytime our equation is in slope-intercept form. Now, you should take a look at some of the other examples in the videos that are linked below. Not all of our equations are going to start off in this form. Sometimes we're actually going to have to do a little bit of work to get the y alone. But once we've done that, whenever we've got something in slope-intercept form, it's pretty easy to look at the slope and the intercept, to plot the intercept, and then use the slope to come up with more points. It's my favorite method of graphing lines because it's usually the least amount of work.